Hey students, this is lesson 722. In this lesson, we're going to learn how to solve compound inequalities and inequalities by balancing method. And we'll just kind of try and compare it to what we did when we solved equations. So here we have three inequalities that we want to solve, or two inequalities and one equality. And we already know how to do this, so I'm just going to go ahead and do this. Let's add 10. So we get 3 times a equals 45, then I need to divide by 3, and I get a equals 15. Okay, so I know that 3 times a minus 10 equals 35. It's true when a is 15. Okay, now here I want the numbers to be greater than 35. Okay, so one thing, we could just do something obvious, like we could do 3 times 100 minus 10. And that's 300 minus 10. That's obviously going to be greater than 35, right? But what I'd like to do is be able to describe all the numbers that will make this true. So I'm going to think of numbers closer, like let's say I do 3 times 20 minus 10. That would give me 60 minus 10, which is 50. And 50 is definitely greater than 35. 3 times 15, let's check that, minus 10, that's 45 minus 10 equals 35. So that is not greater than 35. So 3 times 16 is 48 minus 10 is 38. So my first whole number that works is 16. Anything, but also since 3 times 15 minus 10 is exactly 35, anything like 15.1, 15.2, those would also work. So I can see that my numbers that are working are any number that is greater than 15. Now notice the difference between this answer and this answer. All it is really is the sign. So, so I can really solve this the same way I did the other one. Add 10 to both sides, and then I get this, and divide both sides by 3, and I get my answer, any number greater than 15. Now, to get less than 35, I hope you're already thinking that it's really any number less than 15, like 14, because if I did 3 times 14 minus 10, that would be 42 minus 10 equals 32, and 32 is definitely less than 35. So we can see from this example also that if I just add 10, I get 3a, 3 times a is still less than 45, divide by 3, and I get a is less than 15. Okay, so it seems like solving an inequality is really the same as solving an equation. There's one little catch to it though, and that's when you deal with certain kinds of equations. Like think about this, negative 2 times x is less than 10. Okay, so what numbers can I multiply by negative 2 and be less than 10? And for sure, if it's any number that's a negative number, you'll be less than 10, right? So, so a number like 5. Okay, negative 2 times 5, that's equal to negative 10, and negative 10 is definitely less than 10, right? A number like 0, negative 2 times 0 is equal to 0, and 0 is definitely less than 10. How about it? So far 5 and 0 work, right? How about negative 5? Negative 2 times negative 5, that's actually equal to positive 10, and positive 10 is not less than 10. So this number right here does not work. But notice that these other two numbers are greater than that number. 0 is greater, 5 is greater. So you might be thinking, well, how about negative 4? So 2 times negative 4, negative 2 times negative 4 is positive 8, and 8 is less than 10. So it looks like any number right up to negative 5, but not including negative 5, and from the positive direction. So here's what I'm thinking. If you think about a number like, so 0 worked, right? And 5 worked. And at negative 5, that's where I got a number that didn't work. So all of these numbers in here were working. And I could count on numbers bigger than 5 also working. So my answer to this inequality is any number greater than -5. Now notice that the inequality is opposite the original inequality. So notice it switched around from that. And that happens. To solve this, we would want to divide both sides by -2. And that gives us 1x. But dividing by a negative actually changes the sign of the number. You end up with the sign being opposite. And when that happens, you have to also switch the sign around. So x equals -5. There's another situation where that also happens, and that's when you're dividing. So let's say I have this x, some number divided by -5, and I want to know when that will be greater than, say, -15. Okay? So any positive number would be greater than -15, and so on. Now, if I multiply both sides by -5 like I want to solve this, I would get x, and I'm not going to put the sign down here because I just want to check it. I get -15 times -5 is 75. And what I'm wondering is it the big numbers or numbers greater than 75 that work, or numbers small that's 75 that work? So let's think of a number like 100. If I take 100 divided by -5, that's -20. Is -20 greater than -15? Now think about that. Is the temperature 20 below warmer than the temperature 15 below? And that's not true, right? So that means the numbers that are less than 75 are going to be solutions, like 60. If I take 60 divided by -5, I get -12. And -12 is greater than -15. 12 below is definitely warmer than 15 below. All right. I'm going to ask that you go ahead and solve these 4 problems right now. And if, when you're solving them, if you multiply or divide by a negative, then you're going to switch the sign. All right, so try these, and I'll check back with you. All right, here's your answers. Check them out. Notice that the only one where you had to switch the sign is this one. And the reason you switched the sign is right here. In that step, I divided both sides by -6. When you divide by a negative, you're changing the signs of the answers. So you have to also change the inequality symbol. All right, that's it. Go ahead and try a couple more if you want. And we'll talk about this more next time we meet in class.